Control system. Next module is the time response of control system. So module 3 is the time response of control system. We have studied the frequency response of control system, that is output in S domain. That is C of S we have calculated in the previous module, first module and second module. So that is in the time response means we are calculating we are calculating the output in time domain. The time response of the system is the output of closed loop system as a function of time t, that is C of t. For example, it is just consider this diagram, that is for the closed loop system, and it is a first order system. R of S is the input and G of S is the forward path gain, and H of S is the feedback path gain, and it is a negative feedback, and output is C of S. We know that the C of S divided by R of S is equal to G of S divided by 1 plus G of S into H of S. If you want to find out the output, that is a transfer function. If you want to find out the transfer function, it is C of S divided by R of S, and I will write this G of S divided by 1 plus G of S into H of S as M of S, and I can write, I want C of T actually, so I have to rearrange this equation. C of S is equal to M of S into R of S cross multiplication. Then I can, if I apply for the C of S, if I apply Laplace inverse transformation, then I will get the C of t, or response in time domain I will get. So that is C of t is equal to Laplace inverse into M of S into R of S. So by using this, we can find out any response in time domain. So by using first model and second model, we have calculated transfer function of the any of the system, but in S domain. So that is C of S we calculated. For that is C of S, if you apply Laplace inverse transformation or inverse Laplace transformation, we will get to C of t, and that is a time domain response of control system. So this time domain response of control system has two parts actually. One is a transient response and steady state response. So here this diagram shows the output of control system, that is C of t, in the y-axis C of t output, and with respect to t, that is in x-axis, and we have the time instants are 1t, 2t, 3t, 4t, 5t, and 6t, and so on. And the output is C of t. So there will be a linear increment here, and afterwards small fluctuations. So these fluctuations decreasing, and finally after 60 it is going to be a constant one, and it is still infinity. So this transient response is till this is 60 we are calling actually, and afterwards it is a like it is a constant output we'll get, so that output is called as steady state response. That response is called as steady state response. But as I showed in diagram, it is a straight line, but we won't get a straight line in practically. There will be a small fluctuations, so we can, it is a negligible fluctuations, that is a plus or minus 2% to 5% small variations will be there. So that will be, that is called as steady state response. So or else, so that output of C of t I can represent by using this equation. C of t is equal to Ct of t plus Css of t. So here Ct of t means a transient response, and Css of t means a steady state response. So just remember that the response in time domain contains two parts. One is transient response and a steady state response. The transient response is defined as the part of the time response that goes to zero as time becomes very large. So that is, I can write limit t tends to infinity, Ct of t is equal to 0. So till that point it is called as a transient response. Till when it goes to 0, from the beginning, from t is equal to 0 to 6t, it is a transient response, and remaining part is a steady state response. So next, the transient response is the response of the system when the input changes from one state to other, and the steady state response is the response at a time t approaches infinity. And next we'll see the test signals. So the standard input signals we'll see. As we know, we studied this one. So that is the unit step input, ramp input, impulse function, parabolic function, or a sinusoidal input function. These are all the standard test signals or standard input signals. So we'll see how to represent these signals. First, we'll see step function. So that is represented by u of t is equal to a for t is greater than or equal to 0. So, and for t is less than equal for t is less than 0, it will be 0. So that is represented here. The amplitude of this one is a, and it is u of t, and it is only for the positive half, and for negative side it will be 0. And unit step function means the amplitude is equal to 1, a is equal to 1, so u of t is equal to 1 for t is greater than or equal to 0, and for less than 0 it will be 0. And ramp function is a linear increment, and it is represented by r of t is equal to a into t for t is greater than or equal to 0, and it will be 0 for t is less than 0. So here a means a represents the slope. So that is the y-axis divided by x-axis. Unit ramp function is a is equal to 1 and r of t is equal to only t for t is greater than or equal to 0, and 0 for t is less than 0. So next one is impulse function, that is represented by del of t. It is equal to a for t is equal to 0. At t is equal to 0 only it will be present, and for remaining values of t it will be 0. So that is t is 0 for t is not equal to 0, or del of t is equal to 0 for t is not equal to 0. And parabolic function is r of t is equal to a into t square by 2 for t is greater than or equal to 0, and it is 0 for t is less than 0. So, and these are the standard test signals, and the next this table represents name of the test signals, time domain representation we just saw, and in the Laplace transform of these signals. Sorry, S domain representation. Step function A in time domain, A divided by S in frequency domain. Unit step function, time domain 1, 1 by S is the frequency domain. Ramp function A into T in S domain, A divided by S square. Impulse function, it is a and a divided by s in s domain. Parabolic function a into t square by 2 in time domain, it is a divided by s cube in frequency domain. Now we are just applying Laplace transform for this time domain. We'll get s domain representations. So next we'll see the order of the system.